Quadratic functions reference sheet. This is a foldable, so we're going to fold, once we fill out the form, we're going to fold it and it'll kind of do, what do y'all call that, hamburger booklet format or something. And then we'll be able to open it up, close it. We'll show you as we go along. Let's jump into this. Quadratic equations. We're all familiar with that because we've been working with that for the past month? Y equals ax squared plus bx plus c. Keywords that we need to know. These should all be familiar to you. We've got the y-intercept, maximum value, minimum value, parabola, axis of symmetry, and the vertex. Of course, there are other keywords that we might need to know. These are just the main 5. ROXS, acronym, roots, zeros, x-intercepts, and solutions. Now, don't get confused. That O in there really is the number, it's the number 0. It just looks like a O, but it's really R0XS. Don't let that confuse you. Let's look and see. We have 3 cases. Every possible quadratic equation that we have, that we encounter, is going to be one of these 3 specific entities. We will either touch our x-axis at one location, and we're looking here. Hopefully you can see them a little black. Well, maybe not. Okay. Or we're going to cross and touch the x-axis in 2 locations. That means we have 2 real solutions. Or if we do not touch the x-axis at all, we have no real solutions. Yeah, we'll talk about what solutions we do have. We just know they won't be real. Scroll up a little bit. Let's look at some examples. We'll get a chance to look at some of those 5 key terms that we were talking about above, or keywords. So let me make my picture a little bigger so we can see. A couple of things that we want to find. First things first. I'm going to touch some buttons in red or some locations in red. This is my vertex. In the parabola, you kind of say it's the center of your quadratic function or your parabola, however you want to call it. Vertex, as I said, also will be our maximum or minimum value. In this particular case, because our graph is opening downwards, we know this vertex will be our maximum value. Okay? Maximum value, vertex, both of those are the same thing. Let's look to see where we cross the x-axis. I'm looking here and here. These are my zeros. When I'm on the x-axis, my y value is 0. My x value will be wherever I cross the axis. So that's where the zeros come from. What is the value of y? It's 0. We can use that to solve for x, and thus we call those zeros. Now at the same time, if I cross the y-axis, this is going to be my y-intercept. The zeros are also going to be x-intercepts. I think I said that earlier. Just repeating it because it's very important. You will keep seeing this. What else do we have? Axis of symmetry. Very easy to find as long as you know your vertex. What is my vertex? My vertex is the point -1, +1. We're going to use that. Axis of symmetry. We always want to start off. It is the vertical line that goes through the vertex. So start off with x equals, and then we will put the x coordinate of the vertex. That particular value is -1. So my axis of symmetry, because I wanted to go through the vertex, x equals -1. Scroll up just a little bit. Domain and range. Domain's the set of all of my x's on my parabola. The range is a set of all my y's. Let's do domain first. Domain, we're going to go from the left to the right to consider all of the points, all the x values of those points. Because my parabola is going downwards in both directions forever, actually, because it is a quadratic equation, my domain in most cases will be all real numbers. Now that's the M, that's the symbol for all real numbers. It's kind of a funny looking R. Or we can write, because going from left to right, my furthest most value to the left, or endpoint, is -infinity. Because those arrows mean I'm going on forever. And if I scroll to the right, I have every value leading all the way to a positive infinity. Make sure when you're dealing with infinities that you do put the parentheses. Very important. If you put a bracket, you're saying that you actually reached infinity, and we know we can never reach infinity. If you don't know it, now you do. All right, let's look at a range. Range. I'm going from bottom to top now. So what is my lowest point? Again, looking at those arrows, I'm pointing downwards. So I'm going to start with a -infinity, and I am going to go up. What is my highest point? We can look at my vertex. What is the y-coordinate of my vertex? That is a +1. So I can never reach infinity or -infinity, so I have a parentheses. I do reach 1. So now I want to use my bracket. I think we got everything. Maximum values, vertex, y-intercepts, zeros, axis of symmetry, domain, and range. All right, here's another one. This time my graph, I'm going to do blue. My graph is opening upwards. Draw my little arrows so you can see they're opening upwards. We'll just start at the left-hand side, top, and work our way down. The y-intercepts. Where am I crossing my y-axis? There's my y-axis right here. So I am crossing right here. That's my y-intercept, where I cross the y-axis. You probably remember that from slope-intercept form, y equals mx plus b. We don't have a straight line, so I'm not going to write that equation down. Right? I cannot find my axis of symmetry yet because I don't know my vertex. So let's jump down and find the vertex. There's my little dot. It's my vertex. As you see, my graph is opening upwards, so I this time have a minimum value. That minimum value is -1. I'm looking at the y-coordinate of my vertex. Okay, so here's my vertex. And it's also my minimum value because from this point, all my points lie above that. Okay, so we got the vertex. That is going to be the point 2, -1. We'll come back and use that later. On my x-axis, where I cross the x-axis, those are my x-intercepts, but also we know those to be zeros, because again, the y value is 0. If I wanted to solve for this, I would look to set y equal to 0, and then I can solve for x. In this case, I would find that x is 1 or it is 3. I can now do the axis of symmetry. Okay, see that dashed line? It goes through my vertex. So we, again, want to set up all axis of symmetries by starting off with x equals my x coordinate of my vertex. So x coordinate of vertex is 2. X equals 2. That is my axis of symmetry. Let's look at our domain. Set of x's. I'm going from the left to the right. Now again, my arrows are pointing both directions, so I know it's either going to be all real numbers. I can write the symbol, or I can write the negative infinity. If I go to the right, continuing on to a positive infinity. Every time you have a parabola, if you have those arrows pointing, your domain is going to be all real numbers, leading from negative infinity, ending at positive infinity. My range, go from bottom to top. Because I have a minimum value, I am going to look at the y-coordinate of my vertex. I'm going to start off with a -1, and I am going upwards with those arrows. It means I'm going all the way to a positive infinity. I can never reach infinity, so I put a parentheses. I started off with a -1 where I did reach, so I start off with a bracket. That's what we got for the first page. I'm going to pause this video. We're going to go back, revisit certain things, and we will have a second video for the back side.